The Artemis 2 flight test will be NASA's first mission with crew under Artemis and will pave the way to land the first woman and next man on the moon on Artemis 3. Astronauts on their first flight aboard NASA's Orion spacecraft will confirm all of the spacecraft's systems operate as designed with crew aboard in the actual environment of deep space. Under Artemis, NASA will return humans to the moon for long-term exploration and scientific discovery, gaining the knowledge needed for future missions to worlds beyond, including Mars. The unique Artemis 2 mission profile will build upon the uncrewed Artemis 1 flight test by demonstrating a broad range of SLS and Orion capabilities needed on deep space missions, said Mike Serafin, Artemis mission manager. This mission will prove Orion's critical life support systems are ready to sustain our astronauts on longer duration missions ahead and allow the crew to practice operations essential to the success of Artemis 3. Astros. Carried by a balloon the size of a football stadium, Astros will use a cutting-edge telescope to observe wavelengths of light that aren't visible from the ground. Work has begun on an ambitious new mission that will carry a cutting-edge 8.4-foot, 2.5-meter telescope high into the stratosphere on a balloon. Tentatively planned to launch in December 2023 from Antarctica, Astros, short for Astrophysics Stratospheric Telescope for high spectral resolution observations at sub-millimeter wavelengths, will spend about 3 weeks drifting on air currents above the icy southern continent and achieve several firsts along the way. Managed by NASA's Jet Propulsion Laboratory, Astros observes far-infrared light, or light with wavelengths much longer than what is visible to the human eye. To do that, Astros will need to reach an altitude of about 130,000 feet, 24.6 miles or 40 kilometers, roughly 4 times higher than commercial airliners fly. Though still well below the boundary of space, about 62 miles or 100 kilometers above Earth's surface, it will be high enough to observe light wavelengths blocked by Earth's atmosphere. Atmospheric Remote Sensing Infrared Exoplanet Large Survey. The aerial mission from the European Space Agency, ESA, is a space telescope that can detect which atoms and molecules are present in the atmosphere of an exoplanet, looking to identify their temperatures and chemical processes. The mission will include a NASA instrument, CASE, the contribution to aerial spectroscopy of exoplanets, which will observe clouds and hazes, and provide a more comprehensive picture of the exoplanet atmospheres aerial observes. The GLIDE mission represents a significant leap towards exploring the exosphere, the outermost layer of Earth's atmosphere. As the first mission exclusively dedicated to this region, GLIDE aims to chart the changes occurring there. It will delve into fundamental questions about the exosphere's shape, size, and density, and explore the factors influencing these characteristics over time. The exosphere is a dynamic region, constantly influenced by the space above and the Earth below. Composed almost entirely of hydrogen, which primarily originates from methane or water in Earth's oceans, this hydrogen is broken down by sunlight and gradually ascends to this boundary between our atmosphere and space. Eventually, hydrogen escapes into space, blending into the cosmic expanse. The exosphere extends from about 310 miles above Earth's surface to at least halfway to the Moon, making it a critical area of study for understanding both our planet and the broader universe. The Clario Pathfinder, or CPF, is set to enhance our comprehension of Earth's evolving climate. By capturing highly accurate measurements of sunlight reflected by Earth and the Moon, CPF's data will offer unprecedented precision. These measurements will be 5 to 10 times more accurate than those from current sensors and will adhere to international standards of accuracy. CPF is uniquely designed to maintain this high level of accuracy throughout its operational life. Additionally, it will introduce innovative methods for transferring this high accuracy to other Earth monitoring sensors. This heightened precision is crucial. It increases certainty in our measurements, enabling the detection of subtle climate change trends potentially decades earlier than currently possible. Such detailed and reliable data are indispensable for making well-informed decisions to address and adapt to climate change.